This video will be discussing how to find the variation of the resistance of a thermistor or a semiconductor with change in temperature. So using this, we will then be determining the energy gap of the semiconductor. So all semiconductors have this thing called the valence band, which is where the electrons are in ground state or unexcited state. Then they have this thing called the band gap or energy gap, and at the top of the band gap from the valence band you have this thing called the conduction band, where free electrons go to conduct electricity. So for semiconductors, this band gap has some certain range, and that is the range we're going to be finding in the experiment. So the resistance of a thermistor is given by the following two relations. So using this fact, we can find Eg or the energy band gap using the formula Eg equals to beta k by charge on the electron, and k here is basically a Boltzmann constant.
For this experiment is really simple. So what you have to do is you have a meter bridge, right? So basically the power supply is connected across the two ends of the meter bridge. That's the simplest part. So I have connected it positive to positive and negative to negative. And then the next thing is that on this left hand side you have to connect the positive to the positive of our semiconductor. This is our semiconductor. Okay, so you connected the positive to this end, the left side, and the negative of that will come to the right side. This is already connected to semiconductor. There's nothing you have to do. And then the negative of this end will go to the negative of your galvanometer. The positive of your galvanometer will be connected to the jockey, which we will use to find the balancing length. And then this negative end will be connected to the resistor, and the other end of the resistor to this positive end. And this comes back to the positive end of the battery. Okay, so now let's take readings for this experiment. So the first step is that you will have water at room temperature in the beaker. So you find the temperature of this water using the thermometer that we have here, and you note down the temperature, convert that to Kelvin. That can be done later also. Then this X is the this is the resistance you take out from the box. So we'll be taking out around 100 ohms of resistance, and note that down here. That will be the same for all of our readings. And then we have to find the balancing length, which is L in centimeters. So that we'll do using the jockey. So I've switched on the battery, and so one thing you have to do is you have to check the deflection on either end. So here it's deflecting to the right, and on this end it's deflecting to the left. So you have to check that first. Once that is done, you can be sure that your circuit is connected properly. And then you start from the 0 and slide the jockey until you get the 0 on the galvanometer. So that 0 is at 58 centimeters. So we note that down. It will be different for different apparatus because the semiconductor will be different. So this will be 58 for us, and then you find the R, which is X, which is this, into L, which is this, divided by 1 minus L, because this is a meter scale and it's 1 meter. So whatever you have on this column, you have to convert it to meters, and then you find 1 minus L, and that helps you to find R. Once that's done, you have to take hot water in the beaker. So the hot water will be at around 85 degrees Celsius or something. And so basically you wait for it to cool down to 80 degrees Celsius. Then for 80 degrees Celsius, you find the balancing length and do the calculations. Then wait for it to cool by 5 degrees and repeat it for 75, 70, 65 up to around 40 degrees Celsius. Then you convert to Kelvin, which is 273.15 plus the degree Celsius reading. Then X is the same for all of them. That's the resistance you remove from the resistance box, which was 100 ohms. Then the balancing length will of course be different for each temperature, because you're finding temperature variance of conductivity. Then the R value is basically the way I showed you for room temperature. You have to repeat the same for all the other temperatures, and then you find 1 by T in Kelvin inverse. Just take the reciprocal of that, and then you find log of this value, and that's all for the tabular column. And for the graph, you have to plot 1 by t on the x-axis, like this, and on the y-axis, you'll be plotting the log of r, which is the last column, and you're expecting to get a straight line graph, and basically you have to calculate the slope of this graph, and that slope is this beta that you have here. Then you can find the energy gap using the formula 2 beta k by 1.6 into 10 power minus 90. This is the charge of an electron, and k is basically Boltzmann's constant. So then you can find the energy gap using this formula in.
So for our result, we'll be writing that the resistance of the thermistor is found to decrease exponentially when your temperature increases. And then you will be writing the value of Eg which you found from the experiment.